Okay, so anytime you got a number on the square root, bust it up. This is a square root, so you get it busted up, take the squares out. 16, there is your square right there, 4 and 4. So square root of 16 is the same thing as 4 squared. Or you can keep going and break them down to all their prime factors. That's going to be the same thing as the square root of 2 to the 4th. So either way, you're going to get the same answer. So that square undoes that square root, and you just have 4. Or this square root undoes squares, and if I got 2 to the 4th, that really is the same thing as 2 squared, 2 squared. There's 2 squares in a 4, power of 4. So that's going to undo that one. 2 comes out, undoes that one. 2 comes out, 2 out, 2 out, times them together, and you get 4. So the answer's got to be 4. So what exponent do you put to make the answer be a 4? And it is just the exponent of 1. So it's kind of a trick question, but not too bad. 64, let's break down 64. 64 is an 8 and an 8. Let's keep going. 8 is going to be a 4 and a 2. 2 and a 2. Same thing over here, 4, 2. So it's just made of a bunch of 2's. So you're going to exchange, in place of 64, you're going to put 2 to the 6th. And this time, the index is 3, so it's a cube root. So it's going to undo powers of 3. So how many 3's do you have in a power of 6? And the answer is 2. So you can exchange this power of 6, and you can write it like this. 2 cubed, 2 cubed. Cube and a cube is a power of 6, same thing. So this cube root undoes that cube, this cube root undoes that cube, so 2 is out, 2 is out, and if you bring 2 out and 2 out, 2 out, 2 out, that is 4. But they want the answer in terms of 2. 2 times 2 is 4, that's the same thing as 2 squared. And this is what they want. So the exponent here is going to be 2. 4th root, so now your index is 4. 4th root of 27. If you break down 27, that's a 9 and a 3. Break up the 9, that's a 3 and a 3. So the 4th root of 27 is the same thing as a 3 cubed. Okay, now this 4th root is going to undo powers of 4. And I only got a cube in there, so it is simplified as far as it's going to go. So now if you morph it, this 3 right here is that 3. This 3 goes to the numerator, and then your index of 4 goes to the denominator. Okay, and that's it for NRN 1. Now NRN 2, we introduce irrational numbers and how to simplify irrationals. Add, subtract, times, divide, and this first one is just simplifying. So just like the idea of 4/12 equals 1/3 in irrational, that's called simplifying irrational. Simplifying an irrational, the index is a 2. So we've got to look for squares. We've got to pull out all the squares. So 80, you could go 8 times 10. 8 is a 4 times a 2. 4 is a 2 and a 2. And then a 10 is a 2 times a 5. So move number 1. In place of 80, let's put 2 to the 4 times 5 to the 1. Okay, and it is a square root. So I'm going to undo all the squares. So 2 to the power of 4 is really like there's 2 squares there. A square and a square and a 1. So this square root is going to undo that square. So that means this 2 is out. It's going to undo that square, so this 2 is out. So those are both gone. And whatever you bring out, this is all one big times problem. So times everything together. So you should have a 2 times a 2, which is equal to 4. And on the inside, we just have 5. So 4 goes here, 5 goes there. Okay, next one. You got square root of x to the 4th. So that means it's positive. So it's repeated multiplication. So I've got like a, let's go this way. I got a 1, times square root of x times square root of x times square root of x times square root of x. I got 4 of them. So if I string them out, if I expand it, it's just repeated multiplication. Since these are all underneath the radical, that can be the same thing as 1 times, I can combine them all under 1. X times x times x times x. And anytime you multiply letters, you just add the exponents. So they all have an exponent of 1. So that's really, I'm not going to worry about the 1 anymore. That's the same thing as x to the 1 plus 1 plus 1 plus 1, x to the 4th. Okay, now, it's a square root. So it's going to undo squares. And if I've got a power of 4, that's really 2 squares. So I can exchange that power of 4 and go x squared, and this square root will undo both of those squares, so that means you have x out, and you times it, so your final answer is just going to be x squared. Okay, this was probably the biggest, nastiest one. You got so many letters, so many numbers. First of all, 162. Okay, 162, it's even, so you just punch it in your calculator, start dividing by 2 for whatever you want. If you divide it by 2, it's going to go 2 and 81. Okay, now this is a cube root, so I'm looking for powers of 3. So 81, that's a 9 and a 9. That's a 3, done, 3. Okay. Alright, so I am going to copy and paste 3x squared y. I'm going to leave some space because I'm going to bring some stuff out. And instead of 162, I'm going to go, I just got 2 to the 1. But the 3's, I have 3 to the 4th. And I know the index is 3. I know it's a cube root, so I'm undoing cubes. So instead of 3 to the 4th, I can write that as a cube, and then there's kind of 1 left over. So I want to look at it in terms of that. So this cube root is going to undo that cube. So out here, I'm bringing 3, and that 1 just stays left over. Okay, now if I've got x to the 7, the question is how many cubes are in a power of 7? So I can rewrite that as 2 cubes, x cubed, x1. 1, 2, 3, 4, 5, 6, 7. So that means this cube root is going to undo both these cubes. So out here I'm bringing x and x. And this x1 stays left over. Okay, now the y's, I've got 11. So it's kind of tedious to write them out, so you can kind of just mental math it. How many cubes are in a power of 11? 1 cube is 3, 2 cubes is 6, 3 cubes is 9, 4 cubes is 12. So there's almost 4 cubes. So there are 3 cubes. And that takes me to 9. So that's 3, 6, 9, and 2 left over. So this cube root undoes 3 of these cubes. So that means out here I'm going to bring 3 y's. And the leftover, there's 2 left over. So here we go. Everything you got left over on the inside, you've got a 2 times a 3 times a x times a y squared, and times those together. So you should have a 6 times a x times a y squared. And on the outside, times your numbers, times 3 to 3, and that's a 9. Then let's figure out how many x's we got. I got 2 here, I got 1 here, and 1 here. So if I add them all up, 2 plus 1 plus 1, I should have 4 x's. And the y's, I got 3 here, and I got 1 here. So also I have 4 y's. So that means this is 9. x4, y4, cube root of 6x, y squared. And if you can do that one, then you can do them all. Because that one, It's quite a few steps. Okay, division. So division, you can never have a fraction underneath a radical. So move 1, I'm going to copy this up here. If I got square root of 36 over 10, move 1, 36 tenths, simplify that. So you either do it now or at the end. If you do it at the first, it gives you smaller numbers to work with and it's going to be easier to manipulate. So 36 tenths, if I divide them both by 2, that's the same thing as 18 fifths. Okay, now I can't have a fraction under a radical. So my next move is I'm going to turn that one radical into 2 radicals. So I'm going to go square root of 18 on top and square root of 5 on the bottom. Okay, now anytime you got a number bigger than 4, you got to take the squares out of it. So these are square roots. So 18 I'm going to bust up. 18 is a 9 and a 2, and there's my square. 9 is a 3 squared. So if you got the square root of 3 squared times 2, that square root is going to undo that square. So in place of 18, I am going to take the squares out, and I'm going to substitute it for 3 squared roots of 2. Okay, now on the bottom, we got square root of 5. And you can never leave an irrational in the denominator. So this is now illegal. We can't have a square root on the bottom. So I'm going to times it by itself. Times the bottom by square root of 5, times the top by square root of 5. And if we do that, let me change colors. The top, the 3 is on the outside. On the outside of here, the square root of 5 is just a 1. So the 3 times is the 1, and that gives 3. The insides times each other. So the 2 times is the 5, and that gives a 10. The bottom, the 5 times is the 5, that gives 25. And that is by design. You just created a rational number. So square root of 25 really is the whole number 5. So your answer on top, you got 3 square roots of 10, and on the bottom, you've got the whole number 5. And 10, there's nothing in 10. 10 is just 1, 5, and 1, 2, so there's no squares in 10, so it's done. The 3 and the 5 are both on the outside, so they play together. 3 fifths cannot be simplified, so you're done. That is your final answer. 3 square roots of 10 divided by 5. Okay, the next one is an addition, and these actually are kind of the worst. They're the toughest. So you got 2 square roots of 3 plus 4 square roots of 12. Now, this number out front tells you how many you got. It's your coefficient. If I got, these are like ingredients, and I got a big mixing bowl, and I start throwing them in, 2 square roots of 3. So that's a square root of 3 and a square root of 3. It's 2 of them. Plus you got to add 4 square roots of 12. So there's 1, 2, 3. So these are all your ingredients right here. You got 2 of these that are the same, and you got 4 of these that are the same. But the square roots of 3 are totally different than the square roots of 12, so they cannot combine together. So we're suspicious of the square roots of 12, because in 12 there's a square. So let's break down 12. If you go 3 and 4, 3 is done, 4, there is your square. 4 is 2 squared. So if you're playing with 4 squared, it's 12. Let's replace 12 with a 3 times a 2 squared. Okay, now this square root is going to undo that 2 squared. So it undoes that. So 2 comes out with the 4. So that means on the outside we got 8 square roots of 3. Now, these are now measuring the same ingredient. So if I got 2 square roots of 3 and 8 square roots of 3, if I start throwing them all into a bowl, you are going to have a total of 10 square roots of 3. So the moment that they measure like terms, you can add like terms, and you just add the numbers in front. So how we got the 10 was we just added the 2 and the 8, and you don't change square root of 3. So if I'm throwing all these in, if I got 2 square roots of 3, square root of 3, square root of 3, then I add in 8, There's 1, 2, 3. You get the picture. You add them all up and you count them, and you're going to have 10 square roots of 3. Okay, multiplication problem. These are the best. These are the easiest, fastest, best ones to do. So timesing, you times the coefficients together. So times the 4 and the 3. So the 4 times the 3, that turns into a 12. And you times the underneath, the radicands together. So if you times the 3 and the 6, 3 times 6, that will create an 18. And then 18 is a big number, so we're suspicious. It's a square root, so let's take the squares out of 18. And there is 18 is a 9 times the 2, and 9 is your square. Square root of 9 is just 3. So 9 is 3 squared. So let's substitute. In place of 18, let's go 3 squared times the 2. And that's a square root, so that square root undoes that square, so bring 3 out. So it's going to be 12 times 3 out, and this 2 stays in. So outside you are going to have 36, and on the inside you have a 2. So 36 goes in that box, and then 2 goes in the second box. And that is the same thing as 4 square roots of 3 times 3 square roots of 6. Okay, this one we just did over here. So that's kind of a typo. Let's look at this. So this is another multiplication problem, but now there's letters and a few more numbers, so it's going to be the same idea, just a little more tedious. So times your outsides together. So times this to this. So we're going to go a negative 3m squared multiplied by a negative 5m. So times your numbers, negative 3 times negative 5, that's positive 15. And if you times your letters, you add the exponent, so that's going to be m to the 2 plus 1. So m cubed. Then you got to times the underneaths together. So this times this, 5 times 15, that's going to take you to 75. And then your m's, add the exponent, so it's going to be m to the 2 plus 2. Whoops, 2 plus 2. 2 plus 2 is 4, so you're going to have a total of m to the 4th. Okay, now 75, let's take the squares out of 75. So 75, let's go backwards. We just had a 5 and a 15. 5's done, 15 is a 5 and a 3. So your square, you got 15 m cubed on the outside. On the inside, we got 5 squared times 3 times m squared, because it was m to the 4. And since it's a square root, I want to kind of see things in squares. So this square root undoes that square. So that means 5 comes out. It's gone. 3, I just got one of them. So it's kind of left over. So it stays. But this square root's going to undo both these squares. So m is out, m is out. So everything is out except for that 3. Okay, now on the outside, I had a 15 times a 5, and that's a 75, and then the m's had 3 here and 2 here, so it's a total of 5, and that is your answer. And it's just all times. Okay, last page. So we got a division and then a subtraction. So the division, here we go. Okay, outside of this, there's just an understood 1. So the 2 and the 1 play together, and it is already simplified, so it's just going to stay 2 and 1. But underneath, they play together, 12 and 15. So you can type that fraction in your calculator. Your calculator will simplify fractions for you. So if you hit 12/15, your calculator will change it to 4/5. And then your x's. You got x, you got two x's on bottom, and you got you got two on top and one on bottom. So one of these on top is going to divide out one on bottom. So that means you're going to have 2 over square root 4x, or 2 times the square root of 4x, all over square root of 5. Okay, now this hopefully jumps out at you. Square root of 4, that's a perfect square, because that's the same thing as 2 squared. And that is just the whole number 2. So I am taking the 2 out, so it's going to be 2 times a 2 on the outside, x on the inside, square root 5 on the bottom, and now times your bottom. You cannot leave an irrational in the denominator. So now this is illegal, the square root of 5. So times the bottom by square root of 5, times the top by square root of 5, and we should end up with, on top, we've got 4, and the underneaths times together, so we got 5x. Then on the bottom, the underneath times together, so you've got square root of 25. And that is what we want. So that's a rational number. So on the bottom, really you just have 5. And on top, you got 4 square roots of 5x. Okay, now the 4 and the 5 are both outside, so they play together. 4/5. 4/5 is simplified as far as you can go, so that is your answer. Okay, last one. So you got square roots of 6, square roots of 24, and square roots of 54. So there's 3 totally separate, different terms. So 3 different ingredients. 6 is done, because it's only made of 1, 3, and 1, 2. So they're all square roots. There's no squares in 6. So I'm going to come over here. 2 square roots of 6 is done. Now this 24 there is a square. So I'm going to go 4 and 6. There's my square right there. 2 and 2. 6 is just made of 1, 2, and 1, 3, which we did. So there's no squares in 6. So here's my square. So I'm going to take 2 squared. It's going to be undone by the square root. So out here you've got a -2, and I am bringing a 2 out. And inside I am leaving the 6. So this is going to be a -4 square roots of 6. So I got 2 square roots of 6, and I got a -4 square roots of 6. Bust up to 54. There's a square in 54. Square root of 54 is 9 and 6, and there's your square. 3 and 3, 3 squared. So that square root undoes that square. So 3 comes out, so I got a -2 out, and I'm bringing a 3 out. And inside will stay that 6. So I have a -6 square roots of 6. Now, they are all measuring the same unit. They're all measuring square roots of 6. So when that happens, you just add the numbers up front. So it's 2 plus a -4 plus a -6. So that's the same thing as 2 minus 4 minus 6. And that should take us to a -8 square roots of 6. So if we throw all those together, we're going to have a total of -8 square roots of 6. And that is it.